Hello everyone and welcome to this new video, okay? So in today's video we're going to solve the second problem of the project Euler, okay? Using Python 3, okay? So let's dig into the solution. So summary, okay? In this video I'm going to solve the second problem of the Euler project using three different algorithms, okay? With Python 3. So in the first solution I'm going to use a for loop, okay? And in the second solution, I will use a recursive function. And on the third solution, I'm going to make an infinite loop and break from it when the limit is reached, okay? So we will see each solution with execution time and compare the execution of each solution by the end, okay? We will plot the chart using matplotlib and see which one performs better than the other, okay? We will see which one is going to perform better. So let's dig into it. So let's see the problem. So here's the problem. Let me put it on the side. So here's the problem. Each new item in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 0, the first 10 terms will be from 1 to uh, 89. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. Okay, this is what they asked us to do. Okay, so it asks us to find the sum of the even valued terms. So I highlight this with this color on purpose to show you what we should do, the things that we are going to focus on. Okay, so even valued terms from the Fibonacci sequence. So whose values do not exceed 4 million. Okay, so the value, for example, here it is 5. So this value do not exceed 4 million. So if we kept adding, then the maximal value is 4 million. Okay, so in order to solve this solution, we need to calculate the Fibonacci sequence, okay? And to sum up all the even valued terms from it, okay? So we are going to calculate the Fibonacci numbers and then to sum up all of them, all the even valued terms from it, okay? So this is what we are going to do. And then the first thing that comes to my mind is a loop, okay? I'm thinking of a loop to solve this problem. So there is many ways to express the loop, okay? So using a loop, we can calculate the Fibonacci sequence, and from there, we sum up the even valued terms, okay? So this is my solution, and I've applied this solution for all the three algorithms, okay? So there is many ways to express that. So I created three algorithms that will do the work. So don't get me wrong, there is other ways, okay? So let's dig into it. So here is the first solution. This is the first solution using a for loop. So here is the function. So there is def fib even value terms sum. So this is the name. So there is the initialization. There is the previous, current, and the sum. So each one is initiated by 0. The current is initiated by 1, and the sum by 0. And then I've started the for loop. So for e in range, and then I put the range on it. And then if the current is bigger than the range, I will return the sum, okay? If the current is bigger than the range, I will return the sum. If not, I will see if it is the even valued term. If it is not, then I will keep going. So if it is the even valued term, I will add it to the sum. So as they told us on the first, as they told us to calculate the even valued terms. And from there, after ending this part, I've incremented, okay? So I've calculated the next item of the Fibonacci uh, sequence, okay? So in order to do that, I've put the previous and the current equals the previous, so I will put the value of the current to the previous, and the value of the current is going to be the previous plus the current. So by doing that, I'm avoiding a lot of work, okay? And I'm directly checking if it is an even valued term, okay? So let's read what I've wrote here. So this is the function. As you can see, there is an initialization, then there is the for loop, okay? We would go through the Fibonacci numbers, and if we find an even valued term, we will add it to the sum as long as we don't exceed the range. And if so, we will return the sum. So this is what I have done here. The only return statement if we exceed our range, okay? The 4 million that they talk us about. And then this is the call of the function. I've made a counter in order to track the execution time, okay? So I've put the 4 million as the val on the val, and then I've called the function. So I've put print the result of a normal function with a for loop, and then I've called the function. I have put it as an argument the 4 million, okay? And then I've put it the timer, the start and the stop, and then I've calculated I've printed the time by putting the stop minus the start, okay? And this is the final result, and this is also the execution time, okay? So this is it, the first solution. It was quite easy, okay? There's only a for loop, it's not very heavy. And now let's dig to see the second solution. On the second solution, I've used the recursive function solution. Okay, it is a recursive function. You can build a recursive function that is different from my solution, and this is all right. Okay, so this is one of the solutions. So let's see it how it's working. So I've put the definition of the function def fib even value term sum rec, that stands for recursive. Okay, I've put as an argument the range, okay, and then the previous I've initiated it to 0. So those arguments are not required for on the card, so they are automatically passed in. So the previous is going to initiate to 0, and then the current is going to initiate to 1, and the sum is going to be initiated by 0. Okay. So if the current is bigger, I've put the exit, okay, on the beginning of it, I put the exit. If the current is bigger than the range, and then I will return the sum. If not, I will see if it's an even, if it is an even value term number, okay? So if it is, and then I will increase the sum by adding the sum to the current number and putting it on the sum, okay? And then I've made the same thing as previously. So I've incremented, so we will reach the next Fibonacci sequence number. And then by the end, I've returned the call. So I kept calling the function over and over again, okay? So let's read what I have wrote here. So this is the recursive function that will calculate the result, okay? As you can see, it's doing the same thing as as the for loop, but it keeps calling itself over and over until the limit is reached, okay? So this is what I have done here. And then this is the call function. So I've used this part over here to call the new function. So I've done the same thing. I've put a timer for the start and for the end, and then I've printed the execution time. So I've subtracted the end from the beginning, and this is the final result. As you can see, the results are the same. So 4,006,000 and some, and other thing is the same thing. It's 4,006,000 and same number after that, okay? So it is the same result. And now let's dig into the third solution. So this is the third solution. This is the infinite while loop. So on this solution, it is pretty much the same thing as the for loop. The only thing here is the while doesn't take too much argument. So on the for loop there is an e, and then there is a range, and then there is the n. There is too many arguments, but on the while loop there is not too much argument. So I think that this function is going to do the best job, and is going to work just well. So let's see how I've put it was a while loop, and then there is the condition: if the current is bigger than the range, I'm going to return the sum, and if not, I will see if it is an even number, if it is an even valued term, some number. Okay, so I put the condition, and then after that I put the current, same thing, same mechanism, and then I've calculated the time, and this is the result. As you can see, it is, I think, lower, not that much. This one over here is 0.00036. This one over here is 0.00037, and this one 0.00039. So we don't know which one, because there is not too much difference between them. And now let's see if there is a difference between them. So I've made the test, okay? Here is the test. I've called those three functions 10 times in order to track them and to see which one would perform better, okay? So as you can see, the infinite loop took the lead. So the while loop, the while infinite loop, took the lead. So as you can see here, it's taken the less time over here, and on the first try, on the second try, on the third try, fourth, to up to the 10th try. So the infinite loop took the lead, and after that it is a concurrent. There is concurrency between the recursive function and the for loop. Okay, there is it's not stable between them, but on the infinite loop function, it is stable. It is low. It is wonderful. Okay, so yeah, so as you can see, the infinite loop took the lead. That doesn't mean that the recursive function and the for loop function are slow, okay? It means that the infinite loop took the lead on that time because there is less arguments, okay? So this is one of the reasons why the infinite loop took the lead. So my tip here is to always check for available solutions, and if there is one that stands out, you should take it and put it on your toolbox. Okay, so this is the result, and now let's see how I've made this thing. So how I've made this table, how I have created this one over here. So this is the code. As you can see, there is a for loop, and then I have made the range 10. Okay, so this is the time, number of times that it will be called. The three function will be called, and I'm going to extract the time and put it on a table, and after that I will plot the table on a bar chart. Okay, so I've created the three rows to store the time spent. So this is fun 1 and fun 2 and fun 3, and then I have put the loop as you can, as I've explained it, and then I have appended the the time by taking the stop minus the start. So for each function, so on the first function, on the second function, I appended to fun2, and on the third function, I have appended it to fun3. Okay, and then after that, I plotted. So the execution was were made in a for loop that would execute each function 10 times after getting the data. And I've used matplotlib to plot the bar charts using some methods. Okay, so this is over here. I've made a subplot, and then I've made an index to show how many iteration I do have in my in my bar chart. After that, I've called this method dot bar, and I've created it. So I've put the label, the X label, the Y label, the legend, and the site layout. And then at the end, I've shown the chart. Okay. So yeah, I think this is it for today. I really hope you enjoy it. Thank you for watching, and bye bye. Don't forget to check the GitHub. You will find the code over there on the problem too. Okay. Thank you and bye.